Well, we will continue our discussion. We'll wrap up the lecture part of this course. And again, as I told you earlier, that the topics that we cover in chapter 11, 12, and 15, there are only a few questions related to these three chapters. There may be one or two questions about the acid, about the acid base, and about the not even about the internal forces there. So 11 and 12 are not on the final exam, but 15 there's a couple questions in there. So when we get to that point there, I will point out these are the things that we do expect to do. Okay. So before we jump into chapter 15, we want to continue our discussion on chapter 12 there. We were talking about the solution, the behavior of the solution yesterday, and we finished the first learning objective there. So in the first learning objective, we gave you some definitions about the solution. We talked about like dissolves like, which is a very important concept there. And we told you that a polar bear will dissolve in water because water is polar. So that's the whole idea there. All right. And when you work on the homework questions there, if you are going to be looking into chapter 12 and working on problem after the final exam, which I sincerely hope that most of you will, because after this class, what's left? It's just summer, and it's time for you to go to the beach, and you should take your chemistry book with you, and while laying on the beach and having a great time, and read your chemistry books there. Okay. So if you're looking through the homework questions assigned in that chapter there, we ask you what can be dissolved in what, and then remember that principle there, like dissolves like. Okay. So talking about the behavior of solutions, we are making comparison between the behavior of solution to pure solvent. Okay. So what happens if you have a cup of water? And what happens to the freezing point, the boiling point of water compared to if you dump some table salt in there? Okay, so that's something that we want to look into. And in order to study those different properties, I mean the difference between the behaviors of solution versus the pure solvent, we introduce another measurement for concentration. And this time it's a small m, capital M. Capital M was for molarity, M-O-L-A-R-I-T-Y. And this time we're talking about molality, M-O-L-A-L-I-T-Y. M-O-L-A-L-I-T-Y. So molality, by definition, is the number of moles of solute per kilogram of solvent. Now molarity, by definition, that's the number of moles of solute. That part is the same, per liter of the solution. So the key difference there is in the denominator. In the denominator for molality, the new concentration measurement that we're introducing here, well, we're talking about the mass of the solvent. In chapter 4, when we introduced molarity, well, we were talking about the total volume of the solution. Now there is a subtle difference there. Actually, if you watch on the result when we ask you to prepare a 1 molal solution versus 1 molar solution, actually the volumes are different. Okay, so this is how we define molality. Small m, a number of moles of solute per kilogram of solvent, and then number of moles is mass over molar mass. Okay, so rearranging the equation there, you have 1, 2, 3, and the molality. Total of 4 quantities involved in this equation. If any of the 3, any of the 4, if among these 4, if any of the 3 are given, well, you should be able to figure out the 4th one. Again, we're going back to the calculation part where it's just dimensional analysis. And using dimensional analysis and setting up the conversion, and knowing the definition of the molality and using the conversion factor, you should be able to do, we need you to be able to calculate the quantities if all the others are given. So in this particular equation, remember, when the basic definition appears, there are only 3 quantities in there, but there is a relationship between the mass and molar mass there. So we can introduce the molar mass in this equation there, a total of 4 quantities. If 3 of them are known, the 4th one, we should be able to calculate the 4th one. Okay. So talking about the molality versus the molarity, well, the key difference there is that molality in the denominator. It's the mass in kilograms, mass of the solvent in kilograms. Okay. Okay? And when we express these different types of concentrations in chemistry, their molarity, the one that we have talked about before in chapter 4, we use a capital M. Okay? Molality is a small m, and then we call it a molar solution. And then this is molal. Subtle differences there. Now, is there a difference between these two different concentration measurements? Well, the answer is yes. If we ask you to prepare a 1 molar solution or a 0.1 molar solution of a particular compound there, well, you measure out 0.1 mole of that solid, and you put it in a bottle, and this is something that we did in the titration lab. You put certain amount of the solid in the volumetric flask, and you add water. Now, when you add water, the total volume of the solution would be 1 liter. So after you put the solid in there, you add the water to the mark on the neck of the bottle there, where the meniscus rests right on that mark there. This is a 0.1 molar solution. The total volume would be 1 liter. But if we ask you to prepare a 0.1 molal solution, well, you put the same amount of solute in there, 0.1 mole. But now you need to put 1,000 grams of water in there, 1 kilogram of water. Now, if you mix the two together, you will see actually on that bottle, the total volume of the 0.1 molal is a little bit more than the 0.1 molar solution. So that's the difference there. And again, in the denominator, it's the volume of the solution versus the kilogram, the mass of the solvent in kilogram. And the new concentration that we introduced here, in the denominator, we have mass in kilogram, mass of the solvent in kilogram. So these are the different types of measurements there, and we, when we talk about the in terms of concentration there, and then this is the molality. Then we will be focusing on the unit moles per kilogram. That is for every kilogram of the solvent, how many moles of the solute is dissolved in the solution. Okay. Now, for things like this, and once we know the definition there, we can ask you to do some calculations there. So here, if you have 4.5 gram of naphthalene, you dissolve it in 95.5 gram of carbon tetrachloride. What is the molality? Well, in order to do this kind of calculation, you have to know how we define it. And once you know the definition, well, we can go with the definition. Here, we have 4.5 grams of naphthalene. And we want to convert it into moles first, and according to the dimensional analysis that we do here, 1 mole equals 128 grams. Well, 6.2 there. So we plug in the conversion factor, and once again, we're doing the dimensional analysis. When you do this calculation, you can see gram and gram cancels out. Now, we'll give you the number of moles of the solute. And then, by definition, of the moles of solute divided by the kilogram of solvent. So we have 95.5 gram of carbon tetrachloride. Well, we've got to convert it into kilograms. So 1 kilogram equals to 1,000 grams. And gram cancels out. So that will give you the answer for this question there. So in order to be able to do this kind of question there, calculation there, you have to know how we define molality, and that's what's important there. Okay, so gram has to be converted into kilogram, and you end up with mole per kilogram. So that's the ending unit there. And if you plug in the number correctly,